construction of a cam profile. So in order to construct a cam profile, we need some basic necessities, such as the column conditions are given, such as wire width, base circle diameter, even offset values, as well as the angles for outstroke, return stroke, and angle. These are the basic data which are required for constructing of cam profiles. So I will show the data one by one. The first one, we need to consider about wire height. Denoted by capital L. Value is T/mm. And second one is base circle diameter. Value of base circle diameter is 40 mm. And third one is outstroke value. Okay, but given as angle. Outstroke angle is 60 degree. The next one is a dual. Angle of dual is 30 degree. Then angle for return stroke is 90 degree. The last angle value is called dual, which is 180 degree. The offset value is 10 mm. So name of the provider is equal to the model is knife edge provider. So these are the basic data required to constructing of a cam profile. So in order to draw a cam profile, we need to draw a displacement diagram very beginning. So for the displacement diagram, we need to take in values for constructing of cam profiles. So first we start with the displacement diagram. So for constructing of displacement diagram, we need two data, such as follower height as well as different angles. So we can take y-axis as follower height. In case of x-axis, we consider in the given angles. So first we need to fix in the scale. So in x-axis, 1 centimeter equal to 30 degree. So given angles are in the value of 360 degree, from 0 to 360 degree, we are converting as an x-axis in terms of 1 centimeter equal to 30 degree. And fixing up y-axis, 1 centimeter equal to 10 mm. So these are the fixing up scales for displacement diagram. So first step, if it is fixing the value of 0, then we need to start to draw x-axis. So for x-axis, we have in the value of 360 degree. So we are fixing a scale as 1 centimeter to 30 degree. So in case of 360, we can draw a line for 12 centimeter. It covering the 360 degree of value from 1 centimeter to 360 degree. Then constructing the y-axis, such as given value is T/mm. So 1 centimeter equal to 10 mm, we are fixing the scale. So for T/mm, we need to draw y-axis in terms of 5 centimeter. Similarly, on the other side, we need to complete the structure. The bottom line considering the same x-axis value of 12 centimeter, which is equal to 360 degree. So after constructing this structure, we split into 4 angle values, such as outstroke, dual, return stroke, then dual. We need to fix these 4 cases in the given construction. So first, outstroke value is 60 degree. For y-axis, for x-axis, we have the scale of 1 centimeter to 30 degree. So in order to draw 60 degree, we fix 2 centimeter gap. So this is for outstroke value. So distance is 60 degree in terms of 2 centimeters. So this is the value for outstroke. So next value is 12. So 12 we have to be at 30 degree. So I have to draw 30 degree. We have to be a scale of 1 centimeter. So this is the portion for 12. The next, the third one is return stroke. So value of return stroke is 90 degree. So in conversion of scale, we use the 3 centimeter. So this is value for return stroke. The final value of angle is called abrupt, which is 180 degree. So remaining portion will be marked as abrupt. So value of abrupt is 180 degree. So centimeter is 6 basic structure of displacement diagram. So in the displacement diagram, we need to fixing the uniform velocity motion as the forward motion. The height value and the forward height. So in this problem, ideal case, we need to consideration one is uniform velocity motion or simple harmonic motion or uniform acceleration direction and the cycloid. These are the four basic forward motions are available. In this problem, given forward motion is uniform velocity. So for the case, we need to convert into displacement diagram into uniform velocity motion. So for the case, we need to dividing outstroke as well as return stroke portion as a number of given parts. So dual is ideal stroke, there is no motion, but outstroke and return stroke there is a motion will be available. So for that motion, we need to split the two areas into even number of parts. So in order to divide the particular outstroke as well as return stroke into the even number of parts, we can take this as two even parts. So for the 60 degree, you need to divide that portion into number of even parts. So we are taking the 2 centimeter portion as a outstroke. That outstroke will be a 6 number of even parts. So 1, 2, 3, 4, 5, 6. This is the even parts division for outstroke. Similarly, we have to divide the return stroke as a 6 even parts. So after dividing the portion into the even parts, we need to fixing the name for each parts. 0, 1, 2, 3, 4, 5, 6, 6 dash, 5 dash, 4 dash, 3 dash, 2 dash, 1 dash, and 0 dash. Then we need to connect the 0 and 6 edges. And after connecting the lines, we need to give the name for lines crossing the horizontal as well as vertical. So first one is A, next B, C, D, E, F, G, H, I, J, K, L, M, N. So this is the complete profile for displacement diagram. The concept of displacement diagram is so cam starts to moving from 0 to up to 6 called as outstroke. There will be a forward motion. Then remaining from from Z to H will be a ideal slope, that is a motion. From H to N will be a return slope, that is a next slope will be a motion slope, and finally remaining portion will be a ideal slope, namely called dual. This is the one complete revolution part drawing of a cam profile. So based on this discussion, we are going to convert this data into the required cam profile. To draw a cam profile. So for that, constructing a cam profile, we are requiring the basic data aspects such as base circle value. So base circle value of the problem is 40 mm. So before that, we are going to fixing the scale. So 1 centimeter equal to 10 mm. So in order to constructing of base circle, we need a data such as 50 mm. So converting of 50 mm into centimeter is called 5 centimeter. So we need to draw a base circle value as 5 centimeter. So beginning we need to draw a 5 centimeter circle. After drawing the circle, we have to split into 4 even parts. So after dividing into 4 parts, we need to fixing the 4 angles. So 4 angles namely outstroke, dual, return stroke, and dual. So 4 angles given the problem. So that 4 angles will be marked in the circle. So instead of taking as a 0 degree this portion, so from 0 we need to mark starting to left to right as a 60 degree. So here 0, I need to mark the 60 degree here. This is the value for outstroke. Angle value is 60 degree. And after completing the first portion, we need to move for second portion. So value of the second portion is 30 degree. This is called the dual. This area comes under the dual portion. So after fixing the portion 2, we go to a third area. So angle of value is called 90 degree for a third portion, namely a return stroke. So after marking the third portion, we are supposed to draw the fourth element. So remaining value of dual is called 180 degree. So this is the basic connection. We have to first draw the base circle, then remaining marking of 4 angles. Those are the basic steps. After completing this angle allocation, we are supposed to divide the 2 areas, namely outstroke as well as return stroke, into the number of even parts. So first we need to split into the outstroke portion as a number of even parts. So we have in the 60 degree. So we need to split into the number of even parts. So 1, 2, 3, 4, 5. So we are fixing the 6 even parts. Then after completing the portion 1, then we move to the portion 3. So portion 2 and 4 will be a ideal stroke. So after dividing the portion 1 and 3 as 6 even parts, we need to marking the data from displacement diagram. So we need to measure the basic data such as 0, A plus 1, B, 2C. These are the distance. We need to measure the distance from displacement diagram. Then the distance will be marked by the cam circle. Then after marking this entire value, we need to draw the cam profile. So this is the value of 0, 1, 2, 3, 4, 5, 6. Next one is 6 dash, 5 dash, 4 dash, 3 dash, 2 dash, 1 dash, and 0 dash. So we have to measure the value from 0 to A, then 1 to B, 2 to C, as well as 0 to 6. So after measuring the distance, we need to mark the same value in the given diagram. So first we need to mark the distance of 0 and 1. So 0 and 1 will be there is no distance, so marking place will be here. Then after we need to measure the distance from 1 to B. So such distance will be marked in the portion of here. So here will be a distance will be covered this much level. So we need to mark this distance from displacement diagram. The next one is from 2 to C will be some more distance will be higher than the previous one. So we need to mark from 2. So that point will be lies on here. And similarly, from 3 to D will be some distance over 2. So that distance will be lies on here. So similarly, we have to mark every distance from displacement diagram. So each and every line will be a little bit higher than the previous line. So after marking all points, we need to complete the same procedure for return stroke also. So after marking off entire points from 0 to and 0 dash. So we need to freely draw the profile of cam from 0 to 0 dash. So such lines are lysing entire the curvature. And finally we completing the structure from even dual portion also. So after completing the cam profile, we will give the name for each and every portion, such as A, B, C, D, E, F, G, H, I, J, K, L, M, N, and finally O. So now after completing the profile of cam, we need to fixing the follower left in the top of the portion of the cam. So follower given in the problem is matrix follower, we need to fix in the matrix follower height in the cam profile center axis. So this is the follower height. Follower height is 3 mm. Then bottom will be a knife edge portion. So knife edge portion will be lies on the center of the axis of the cam. So this profile is called knife edge profile with. So this is knife edge profile line. This portion will be called base circle. Then this segment will be called as cam profile. So this is the construction of entire cam profile for the given condition. So this is where we need to draw the cam profile from based on